This is lab 5, resonance in an LRC circuit. You can see the main components. We have a 3-channel amplifier. Inputs are on top. Output for those two inputs is on the bottom. There's a second channel, input, output, third channel, input and output, and the on-off switch. We'll leave it off for now. We again have our 4-channel oscilloscope. Inductor coil. We're going to be connecting between these two pins here, one's 1500 and the 0 here. And as usual, our resistor capacitor board. And you're going to need a large collection of these banana cables. We recommend getting some red ones, some black ones. If you can pick up a few yellow or other colors, that's good too. You'll also need a couple of coaxial or BNC coaxial cables. And you should also pick up some connectors. You'll need some barrel connectors for connecting together BNC cables or for dividing BNC cables, as well as for going from BNC to banana connectors. You're going to need to wire up a circuit, which is fairly complicated. We recommend hooking up the oscilloscope at the end, and instead of hooking up the oscilloscope, start first by hooking the wave generator on the oscilloscope up to the LRC, build that circuit, and then we'll connect together those components to the 3-channel amplifier and the oscilloscope. Alright, so we have this setup for LCR circuit. We've kind of removed all the cables and everything else, just left in main components here. This is like the 5th time I've tried this. Everything's gone wrong, or something's always gone wrong so far, so let's try it one more time. We're going to start by connecting the wave generator of the oscilloscope, which is over here on this pin, to the LCR part of the circuit. And then after we got that hooked up, we'll connect the 3 channels of our preamplifier to the voltages across the resistor, capacitor, and inductor. And I'll probably mess something up, but we'll just keep going anyway. So first thing is, here's the output of the wave generator. We're going to hook to BNC cable. You see how I just kind of pushed that on there just gently and then twisted it very again gently. We're going to need to go from the output of that wave generator. Part of that wave generator output will go over here so we can keep track of it, and the other half we'll use, or the other path we'll use to drive the LCR circuit. So I just put an adapter on here with a T on it. That lets me split that drive signal. And let's take care of the easy part of that. You're going to need to monitor that in channel 4 of your oscilloscope. So now I've got that hooked up to one part of the T. And the other half of the T we'd like to use to drive our circuit. Now our circuit is using these banana plug connectors, so we're going to have to come off of this BNC connector, put another cable on there, and we'll go to one of these adapters. And you notice it doesn't plug in. So we're going to need another barrel connector here, which we plug in, and now we can plug in that banana plug adapter. So this now is essentially hooked up to the wave generator. Positive and negative terminals are ground and positive terminal out here. And let's now hook this into the LCR circuit. We'll start with the ground here, black pin, or with the tab on it, and that will go to this pin right here, labeled 1500 on the large inductor. And the other terminal of that banana plug, the drive from the wave generator, that will hook into, again, a banana plug. And we'll go over to one of the 1 k ohm resistors. If you look at your board, you're looking for brown, black, red. That's 1 k ohm. There's one here. There's another one up here. We're going to use this one on top. That's, again, 1 k ohm resistor. And we'll use that one because it's got a nice separate pin here on the side. So now we've got part of the circuit hooked in. It's, of course, the other end of this coil isn't connected to anything, and this feels kind of loose here, which is not good. This terminal will go over to our 1 nanofarad capacitor, so let's start working on that. I'm going to use this other color here. It's not really going to be ground anymore. I'm going to use a yellow banana plug. You could use anything you'd like, whether it's black or red for this interior one doesn't really matter. And actually, since this is going black to red, we really should, it's a little bit confusing, but we're going to go over here to this, this black pin. That's going to be the lower voltage side of this 1 nanofarad capacitor. And then we're going to come out of the other side of the capacitor. There's no good choice here because it's in the middle of the circuit. And I'm going to put this black connector, black banana plug into the higher potential side, and that needs to connect up to our resistor. All right, so that was almost certainly a little bit confusing. So what you want to do is, after you've wired this up, and we've only got part of the circuit wired up, you want to check that the signal that comes out of the wave generator. Just kind of lay your hands on the cable, follow it around. You'll see that one part goes over to the scope and the other part goes to these black and red connectors, or banana plugs. So on the negative side, the ground side of this terminal goes over to this black pin on the coil, and the red side goes over to the resistor. So we'll follow the positive side, goes to the resistor, goes through this 1 kΩ resistor, comes out of the 1 kΩ resistor, goes again to the hot side of this capacitor, red, goes through the capacitor, goes from the capacitor over to the inductor, goes through the inductor, comes back out, and goes to the ground pin of the wave generator. So that was a complete path starting from the wave generator, returning to wave generator. We've now got the LCR hooked up to that. So let's now finish the rest of the circuit. We'll do the easy stuff first, or start if I have some cables here. You'll need to hook up each one of these outputs, the BNC connectors on the 3-channel amp, to the corresponding inputs on the scope. So let's start just with channel 1, and you'll be able to put together all the other ones, obviously. So that's output of the output of the 3-channel amplifier goes to channel 1, input of the scope, that's channel 1. And we need you'll need 2 more BNC cables to hook up the other outputs. Now, of course, there's nothing going into these inputs yet. We'll take care of that in just a second. Let me do the second channel here, second output of the preamp going to second input of the scope. And I'll need 1 more BNC cable to plug in the last one, but anyway, that's obvious how you do that. So let's start with the inputs here, though. This first channel we'll use to measure, say, the voltage across the inductor. And you want to double check against the schematic if that's actually right, or the schematic in the lab manual. So the thing here is, notice that we've got red and black pins, positive and negative, if you will, and red and black here. And we'd like to respect that. It just makes it easier to understand that you've got everything hooked up right. So let's use a red banana plug. Just plug it into the top of this connector right here. And we'll go over to the red pin on channel 1, and then the black pin here goes to the black pin here. And the whole point of this preamp stage is that it is isolated so that these inputs aren't actually, this black and red one aren't actually connected to ground. And that will let us measure the potentials at different locations without grounding any of those inputs. And let's hook up, say, the second channel. Second channel input here is used to measure the voltage across the next component, which is the capacitor. So let's again respect the black and red. Black pin here, red pin here across our capacitor. So the black pin on channel 2 go to the black pin of the capacitor, and we'll need another another banana plug here, red pin, and to red pin. And you can see already we're not done. We have a whole nother channel to hook up. We need to hook up the output to the scope. We need to hook these 2 input pins across the preamplifier right here. And let's go ahead and hook up the inputs. Here is black pin. Go to black pin on the resistor, and red goes to red. And now the only thing that's left to do is to find a BNC cable and hook up that last connector. And hopefully somewhere around here we actually have another one. We don't. We have none left. We don't have enough. All right, we're looking. These are like massively long. We don't have a BNC cable. We need just 1 more, and we can do it. All right, 5 minutes later. All right, we're back. We got one more cable. There's BNC cable, and now we can hook up to channel 3. And so we've got channel 1 input going across the inductor, and it's got an output, and you can see there's just a lot of wires right here. And the important thing here is that usually when you build it up, that you build it up in some sensible order. And again, we recommend building the LCR first, and then hooking up the preamp. And finally, let's turn on the scope. We'll again go through its usual set of diagnostic checks, and we can also turn on this preamplifier. You should see that output light turns red. Scope's still getting ready. Let's give it a minute. All right, looks like it's all set, or almost all set. Let's start by turning on the wave generator. There it goes. We're good. Start up the wave generator, and someone obviously left it or had used it previously, and you can see that 3 of the channels are lit up. So let's also turn on channel 4. We can now see, the channels yellow, green, blue, and red. Yellow, green, blue, and red. There something showing up. Let's also, if we like, we can hit the auto scale, and that will stare at it and figure out if there's anything going on there. The wave generator is something we're going to want to adjust. So let's start off by punching that button. It's obviously on. We're generating a wave, a sine wave, and now the frequency here is set at 100 Hertz, which is kind of low. So let's just start by adjusting that. So I've selected frequency, and you see that green knob is kind of lit up. So again, we can push this button, and now it's starting to show something. So let's just hit the auto scale here. Let it think about that a little bit. Now that looks more reasonable. We've got a voltage across. This is the voltage across the inductor, channel 1. There's channel 2, which is voltage across the capacitor. There's channel 3, which is voltage across the resistor, and there is our drive. And now as we sweep the frequency, again, I'm going to hit this. Frequency is active. It's running around 10 kilohertz. It's going to sweep that frequency, and let's see if we can get it to do something reasonable. Actually, there you can see there's going to be a large response out of that. That would be the inductor. Let's just back off here. Let's just check what this thing thinks it's triggering on. Trigger type 1, source 1. Let's trigger off with channel 4 actually. 1, 2, 3, 4. Since that's the wave generator, it's always going to be present and a nice signal. And I'm just going to turn these down just a little bit. Channel 1, channel 2, and that way if something interesting happens, we better not mess with that one. Or that's our trigger on channel 4. And again, let's go back to the wave generator, sweep the frequency. It's now about 8.6 kilohertz, and showing no signs of anything. All right, so let's stop there. All right, so we've zoomed in on the oscilloscope so you can kind of see what's going on with the controls there. Channel 1 on top here is the voltage across the inductor. Channel 2 is the voltage across the capacitor. And channel 3, this blue trace, is the voltage across the resistor. Actually, and the trace at the bottom is just what's being produced by the wave generator. It's what's being applied or driving the circuit. And I've got the wave generator button pushed here so that the frequency control is active. If I sweep the main control knob here, I can vary the frequency. And I've also got the trigger set. If you go up here and push this trigger button, it's set on channel 4, the drive, as the source. Again, you can hit this soft key and go through things. And the one that works best for the full range is not 1, 2, or 3, but the actual drive, since that has a constant amplitude. All right, so again, let's go back to the wave generator control. And you can see this frequency knob is active. And if we start to adjust here, let's look at the voltage across the resistor. That's the blue trace here, and I'm at relatively low frequency now, about 3.4 kilohertz. You can see I'm not getting much voltage across the resistor, but now as I increase the frequency, you can see that response increases. It's getting easy to see that actually the amplitude is bigger. Of course, the frequency is also changing. I'm now up around 8.6 kilohertz, and things are actually getting smaller as I'm increasing the frequency. There's 10, and it's getting smaller again. So if I go back, decrease the frequency, you can see that there's a pretty well-defined resonance there, somewhere in this particular case in the range of 7 or 8, maybe 9 kilohertz. Looks a bit lower, it's somewhere in there. So I'm just going back and forth in frequency, and that's the phenomenon of resonance. Of course, you may have also seen these other traces changing, and you'll want to record, or you'll be recording all of these so you get the voltage across resistor, capacitor, inductor. Anyway, that's a quick look at the setup and a little bit about what the data looks like. It is helpful to keep these channels straight and to understand generally what they're going to do.